Hello YouTube, Brandon here. Sorry for the lack of updates. I'll try to be more consistent going forward. Today I would like to show an example of traditional voice coding versus natural speech programming, which is what Vocal implements. The primary difference is that with traditional voice coding, you are literally saying what it is that you want your computer to type for you. So if you want to create a loop, you say for int I equals 0, I less than 10, I plus plus, which is very cumbersome and it's very fragile and very rigid to, you have to kind of say exactly what you're trying to go for. Whereas with natural speech programming, you have this layer of ChatGPT between what you say and what is typed, so that you don't actually have to spell out code, though you can say create a for loop and it'll create a for loop for you, or you can literally spell out what the for loop that you're looking for to create it. So you can kind of pick and choose the level of abstraction that you like. And that is kind of the primary difference between the voice coding of old and the natural speech programming of new, is that you can generate code at whichever level of abstraction you're looking for. If you want to be precise, you can be precise. If you want to be imprecise, you can be imprecise. The job is then up to the LLM to kind of fill in the gaps for you. So I would like to show an example of voice coding versus natural speech programming by implementing the same program, first using voice coding and then using natural speech programming. So to begin with, I'm going to be using Serenade, so I can show you my settings. I'm going to be using Serenade for the voice coding, and then later I'll be using Gemini 1.5 Pro latest for the natural speech programming. Since I have Serenade as my intent detector, everything I say is going to go to Serenade. Let me just make sure things are, oh, it's disabled, so that's why it's not listening, but let me go ahead and enable it. Test, 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 test. Okay, we're good. All right, so I'm going to go ahead and create this very simple program, which is just going to calculate factorials. Add class main, end of line, new line, tab, add function main, right, insert string, bracket, close bracket, insert args, end of line, new line, tab, insert scanner, scanner equals new scanner, open paren, system.in, close paren, semicolon, new line, insert system.out.print, open paren, string enter a non-negative integer, insert close paren, semicolon, new line, insert int number equals scanner.nextInt, open paren, close paren, insert semicolon, new line, insert if number is less than 0, end of line, new line, tab, insert system.out.println, open paren, insert open paren, insert string, please enter a non-negative integer, insert close paren, semicolon. Go to line 9, end of line, add else, new line, tab, insert long result equals factorial of number, semicolon, new line, insert system.out.println, insert open paren, string factorial of, undo, insert open paren, insert string factorial of, insert plus number plus, insert plus string is, undo, insert string is space, insert space, nope, undo, insert plus result, close paren, semicolon, go to line 12, end of line, new line, insert scanner.close, open paren, close paren, semicolon. Go to line 14, end of line. New line. Insert public static long factorial. Insert open paren, int in. Insert close paren. Insert curly bracket. A new line. Insert close bracket. Undo. Insert closing curly bracket. Go to line 16, end of line, new line. Tab. Insert long result equals 1, semicolon. New line. Insert for int I equals 1, or I is less than or equal to n, I plus plus. Undo. Undo. Insert I less than or equal to n, I plus plus. Undo. Right. Insert I less than or equal to n. Right. Insert I plus plus. End of line, new line. Tab. Insert result times equal I, semicolon. Insert undo. Go to line 20, end of line. New line. Insert return result, semicolon. Go to line 1. New line. Go to line 1. Insert import java.util.scanner, semicolon. Okay, so that wasn't too bad. That's traditional voice coding. As you can see, I do have to kind of spell out every single thing that I want to be typed. That is better than nothing, but it is not the best we can do, especially with the introduction of ChatGPT and more broadly LLMs. So now I'm going to show the same program being coded using natural speech programming. Edit mode. Add class main. Add main function. In the main function, do scanner equals new scanner system in, system out print line, enter a non-negative integer, int number equals scanner next int. Actually make the print line just print. After that, do if number is less than 0, system out print line, please enter a non-negative integer. Get rid of that new line and then do else long result equals factorial of number, system out print line, factorial of number is result. And then do a scanner close after that. And give me a factorial function that computes factorial. And give me a import scanner. Can you make the factorial non-recursive? Looks good. Okay, so that's kind of the difference between the two, is that what I say, it just needs to be close enough to what I'm looking for, and it will generate the code that is most appropriate for that to complete that task. If I wanted to, I could have done the Same style that I did with voice coding, where I can do one line at a time, one line at a time, one line at a time. Or I can do entire blocks of code at a time. For example, if I do something like add Java docs to this, looks good. See there, I actually kind of just generated comments, whereas if I was doing voice coding, I'd have to implement those myself. That doesn't kind of show like the real power of natural speech programming, but it does at least show that what I say doesn't have to correlate one-to-one with what is typed. If I want to correlate one-to-one with what I type, I can simply ask, as I'm natural speech programming, to not try to go beyond the scope of what I'm saying, but to simply type exactly what I'm saying. I think that shows kind of the very basic idea between voice coding and natural speech programming. I will be releasing more videos showing more of the benefits of natural speech programming over voice coding. So if you're interested in seeing those, please like, share, subscribe, and thanks for watching.